Good afternoon, DockerCon. Good lunch? Yeah. I know it's a little cold in here. You might be a little sleepy because after lunch and fall asleep, but we're getting our second session today in Docker in production. This is what I like to say. This is where the rubber meets the road, real life stories. And today we'll have Jonelle Taylor. She is a platform engineer at Metlife, and she'll tell you all about building a NoSQL ship in your enterprise. Okay, so let's have a big DockerCon welcome for Jonelle.
Awesome, thank you. Thank you, hello, how are you guys? I need you guys to wake up a little bit more. Awesome. Get a round of applause if you guys are excited to be at DockerCon this year. Yeah? Awesome. Can I get a raise of hands to see how many of you guys have built a Docker image before? Raise your hand. Awesome, okay. Raise your hand if you've used Play with Docker. Okay. Raise your hand if you've got Docker in a production environment. Awesome, great, cool. So like she said, I'm Jonelle Taylor. I'm a platform engineer from Metlife, and today we're going to be talking about building your NoSQL ship. And of course the clicker isn't working. All right, so a little bit about myself. I went to the University of North Carolina in Wilmington, graduated in 2015. I worked for a company called South Atlantic Services for a little bit before taking a full-time opportunity at Metlife. While I was at Metlife, I participated in the Metlife Technical University, a 20-week program where they teach you business acumen and technical specific training. After that, I started working as a database engineer, NoSQL databases, specifically MongoDB. From there, I started working on the first ModSquad innovation team. I'll get into that a little bit later on today. From there, I started working on the container and open source platform team, who's managed by Jeff Murr, who's actually here today. And then from there, I have worked on ModSquad 2 and currently ModSquad 3. Awesome. So originally, this talk was entitled, How an Enterprise Transition from a Relational Database to a NoSQL Database Using Agile and Docker. After writing the talk, I think it's more appropriate that we entitle it, How an Enterprise Containerize Your NoSQL Database Using Agile and Docker. We didn't quite transition using one or the other, we more so just integrated our NoSQL in. Today, what we'll talk about, we'll do a little bit of Metlife background. We'll talk about the ModSquad innovation team. I'll go through a platform architecture, and we'll talk about the fundamental challenges that we face there. We'll also talk about in-depth database design. I'll give you some Dockerfile examples, and we'll talk about ModSquad 2, ModSquad 3, room for improvement, and we'll end it up with Q&A. So a lot of platform engineers and engineers in general have the hard question of, how do I design a portable solution that can lift and shift into any environment, on cloud or on premise? How can I integrate open source software with legacy code? And should I include a NoSQL database in my application stack? Today, you'll understand the hurdles and that you have to face when containerizing your NoSQL database and bringing it into production. A little bit of Metlife background. If you're not familiar with Metlife, Metlife is a leading insurance company. We've been around for over 150 years, and we're globally operating in 50 countries around the world. Being 150 years old, of course, we have a lot of monolithical applications running code in production. We also have around hundreds of NoSQL databases as backend sources of record in the US alone. And we have thousands of relational databases as backend sources of record in the US alone. We also have production environments in the cloud and on-premise, of course. ModSquad innovation team had the hard challenge to not only design something that could go in cloud and on-premise, but it also had to be able to utilize its resources. We find that a lot of insurance companies they design applications that only get used during peak times, right? So how can we actually use the full resources that we provided? ModSquad innovation team figured that out. They are actually the team that came up with the architecture for the Metlife Global Sales and Services product, also known as GSSP. How do we do that? Raise of hands to see if you guys are familiar with Agile. Anyone? Awesome. So this is an Agile team. We worked in 2-week sprints. Being able to work in 2-week sprints, we were able to come up with a cadence to where we were able to pivot when we needed to pivot, testing out new technologies, figuring out if we could integrate it with our stack. If it didn't work, we would try the next thing. Because we were able to pivot, we created this culture for learning. What we would do is we would have daily scrums. In these daily scrums, we would talk about what you did the day before, what you planned on doing, and where any of your blockers were. It was a good opportunity for you to just see what the team was working on, and if you needed any help, you could always have someone to help you there. Additionally, we would have things called innovation meetings. These innovation meetings were bi-weekly meetings. We would talk about things that we couldn't quite come to an agreement with in the daily scrum. So for instance, we would talk about things like, should we really integrate open source things, or how can we try and containerize our enterprise products? That was when we came up with those types of decisions. And GSSP was one of Metlife's first microservice-based applications. So the platform architecture for GSSP, you'll see that we had 3 managers and 6 worker nodes. Our workload was distributed across the worker nodes, of course. We were running in the cloud. These are all Linux boxes. We had our separate DTR. It's not pictured here, but we did have a separate DTR. And then these 2 little leaves here denotate MongoDB. So we were running MongoDB in containers on 2 of our nodes in our primary region. I'll get a little bit more into that when we dive more into the database design. Cool. So we were challenged to look at open source things. At the time, our enterprise monitoring solutions weren't quite compatible with Docker. So we looked at things like Prometheus and Grafana. I've actually got a little dashboard here, and this just shows you we've got some things up, some things down. I think this specifically is looking at some memory, I think in CPU utilization and a lab environment. So you can customize these dashboards to whatever you need. We later did integrate these dashboards and these monitoring services with our enterprise solution, ServiceNow. So we were able to kick off these alerts, monitor our environment and kick off these alerts, send them to ServiceNow, send them out to your operational teams. They react accordingly. We also integrated EMC Avamar as a backup solution. I'll jump into that a little bit later. One thing I really want you guys to take away is challenge how your organization sees open source. You'll see a lot of times they're slow to adopt some open source technologies, but you'll see in the open source world and community, it's extremely helpful to be able to keep up and find some technology that you can grow, your application can grow, and the technology is actually keeping good speed. So our microservices architecture, I'm not going to go too deep into this, but we had 66 different microservices. They were all containerized, running in those worker nodes. Just to hit on a few, we did containerize MongoDB. We containerized Redis, RabbitMQ, and Data Power, just to name a few. And again, these are all running on our worker nodes. So what were some of the fundamental challenges? Testing, operationalizing, business logic, business continuity. So you really had to take a disruptive testing approach because Docker is always constantly giving out new patches, new kernels. So you have to make sure that you're keeping up with those new releases. There's constant churn in our testing and lab environments. And that's kind of hard from an application team to see sometimes. You'll see they kind of push back when you're constantly telling them, hey, we're upgrading the environment. Well, it is what it is. We did things like war rooms. From there, we would have an engineering team and an operations team in 2 different rooms, and our engineering team would cause the environment to fail some way, and our operation teams would have to bring it back up using our SOPs. This was a great exercise. Honestly, it helped our operations teams feel more comfortable. And that's really a big thing, making sure that they feel confident and able to support the environment. Challenging our current DevOps models. What I mean by that is true CI/CD, continuous integration, continuous development, making sure that, hey guys, we are upgrading. You're gonna have to change your code. You're gonna have to make sure that you're committing it, checking it. We use things like Bamboo and Bitbucket and UCD to orchestrate, build, orchestrate, and ship into our environments. Operationalizing. That was a big challenge for us. How do we take this cool little toy that we built and get a team to truly support it? And again, that's going to really come down to making sure that those guys, those people feel comfortable working with them, knowledge transfers. We had constant knowledge transfers, a lot of training. And one thing that you can do to help them feel comfortable is to just have them validate your SOPs, of course, run through your test cases, make sure that they're valid test cases, talk to them, listen to them, understand what their concerns are, and really challenge those rigid operating models. When I say rigid operating models, how many of you guys are familiar with once you get something in QA or production, it doesn't change? Anybody? Yeah, a little bit? Yeah, I see a couple hands. It's okay. I won't tell your bosses. But yeah, you really have to challenge that, hey guys, this is what it is now, but they're coming up with another release. You know, maybe you can't do it every month, but maybe once a quarter or once every other quarter, but making sure you get your application development teams into that cadence. It's really gonna help out in the long run. Business continuity, integrating your ancillary tools. I kind of touched on this a little bit earlier with ServiceNow and Avamar, EMC Avamar. Those were some of our enterprise solutions. And it was kind of tough sometimes to integrate those into the Docker environment. We saw that a lot of times these third-party vendors were actually not compatible with Docker in its earlier days. So we did have to look at container-native products. An example of one of these container-native products would be Metlife uses IBM Guardium to audit the databases. At the time, Guardium was not compatible with MongoDB and containers, so we actually had to come up with our own auditing system. Mongo has its own native audit logging, so we had to enable that. So what was Metlife looking for in NoSQL and open source? Ultimately, Metlife was looking for a front-end web persistence layer that could be easily queried. We were looking for something that was highly available, fault-tolerant, gave us minimal vendor lock-in. We looked at technologies like Hazelcast and GraphDB, but again, ultimately, we did choose Mongo because of its portability and its ease of deployment in any cloud or on-premise environment. So I kind of hit on this earlier. We use Mongo because of its portability, its ability to query multiple attributes. In GSSP, Mongo holds configuration and session data. If you don't know what that means, it's a cache. We would use it to pull up the different panes. For example, you're logged onto the Metlife page. You want to go look at some of your policies. You might have a auto policy, home policy, life policy. We just use Mongo to populate those different panes super quickly for you. Our sales service, our sales product uses Mongo to aggregate and transform data, while our servicing product uses Mongo to separate logical schemas. In this microservice architecture, each microservice got its own database. So, this is the meat, guys. Database architecture. Hold on, so are you guys still awake? I have to make sure. You guys are quiet, awesome. So this is our database architecture. You'll see we did implement this in a cloud environment. I'm only showing the Mongo nodes here. These are containerized Mongo databases. We've got 2 running on our primary side, 3 running on our disaster recovery side. Again, that is high availability. We set up priority here. If anything happens on our primary side, a new master will automatically be reelected. This was one of our test cases that we validated. It took, on average, less than 2 seconds for a new master to be elected, no downtime to the application at all. So again, if your primary side goes down, you are going to get a new master elected on your disaster recovery side. These are cross-regional deployments. We have one in Cloud Provider West, one in Cloud Provider East. What that looks like to you, those are 2 separate UCP swarm clusters. And we were actually able to connect the 2 using express routes. This implementation is an IaaS implementation. So again, we did use express routes to have cross-regional connectivity. The biggest question, let me see, how many of you guys want to know how we achieve persistent storage? Yeah, I want every hand to go up right there. So how did we do it? We used Azure, we used block storage. We mounted a block storage to the virtual machine. From there, we abstracted volumes from inside the container to the underlying host that it was sitting in. We were actually able to see near real-time writing from the container to the actual host, so that was good. We were also able to see near real-time replication across the regions, so there wasn't really any latency or lag there. I'll get into an example of what a compose file and a stack file would look like on how we actually created those abstracted volumes. We also used Avamar as a file system backup. Avamar is our enterprise backup solution. So what we ended up doing was writing a custom script. And what this script would do is it would go on one of the hidden secondary Mongo nodes. It would put the container in a stop pause state, and then Avamar would come take a file system backup and then port that back up to the Avamar appliance, and that's just standard. Again, we also backed up our DTR and our UCP using the same similar method. You can back it up running a script, and then Avamar just comes and picks that up and ports it away. Another thing to note, we did use Mongo Enterprise Edition. We did have encryption here. There was encryption at rest, and there was encryption between the databases. So database to database intercommunication was encrypted using their key files, of course. So a Docker file example. Again, we did have to create our own containers here. At the time, Mongo did not have an official image in the Docker Hub. I still think to this day they don't have the Enterprise Edition. I think they have the Community Edition. So this is how we created it. You'll see that I start with a RHEL 7 base here. From there, I add some common labels. It's really important that you add some good labels. It'll help with your metadata and help with your operation teams, kind of getting similar and used to the same things. From there, you'll see that I've actually got a link to the Mongo Enterprise repository. It just goes and pulls it down, it layers it on, starts with RHEL 7, builds out the Mongo database there. I add some directories for my secrets, key files. I'll get into that, certificates. I add in a config file. I expose my port, and then I start the MongoD process in the background. This is an example configuration file. This is a pretty standard configuration file. You can go look at MongoDB documentation and get something similar to this. Here, the main thing to notice is that I do have key files here. The cool thing about swarm mode, you're able to do secrets. Secrets is a big thing when it comes to key management. You can inject your key file, your certificate at time of orchestration, which is a big deal. We were finding that we would have a production image and a non-production image, and it was just turning into a huge nightmare. On each application had its own image. So this kind of helps. I can build one image and just change the key file at orchestration time. This is the example of the encryption key file here. You got your Mongo data directories. Another thing to notice is I did cap the storage engine. There are a lot of concerns about memory usage and things like that when using databases and containerized environments. So we did go ahead and just cap the storage engine at 5 gigs. What that looks like being capped from the Mongo perspective is Mongo process itself will not let you use more than 5 gigs. There might be a little bit of buffer there that you need to put in for the actual container cap, but I'll get into that. Another thing to note is that we did create our own audit files. Again, I talked on that earlier. This audit file is the same kind of as our database files. It would sit on the underlying host, and Avamar would come and grab those. So this is an example of what your compose file would look like. This is compose version 3. Stack, not compose. So we start with a Mongo image, 3.4 image. We've got our ports inside the container to outside the container. We've got our Mongo logs. This is how we abstracted the volumes, just porting it back to the underlying host that it's sitting in. This is a memory cap for the container. So again, there was a 5 limit Wiretagger cache cap, and on top of that, I put in another 10 gig cap on the actual container itself. One thing to note, if your container does reach that limit, Docker kernel will actually kill the container. So if that is something that you want to implement, make sure that if it does hit that, it will come and kill the container. As you see, I have it commented out. We did pin the Mongo nodes to certain underlying hosts. Again, those hosts where we had the block storage. Our key files, again, when you're using your compose and your stack files, this is when you can actually ingest your key files, your certificates into the container. So here I'm saying, go grab this key file. I created it through UCP. You can create it via command line and stick it in the container. I also want to change the ownership of that file to make sure that Mongo can actually read it. And then another thing to note, we've got Mongo in its own overlay. I did hit on this a little bit earlier. Mongo is actually not in the Docker network. When we use it, it's actually using the underlying express routes. But I did go ahead and add it, just so when we're filtering through UCP, you can check how many containers are in a certain network. So I went ahead and added that. So ModSquad 2. ModSquad 2 looked at the differences in swarm mode and classic mode. We looked at Compose version 2 and Compose version 3. There were some big changes in Compose version 2 and version 3. You'll see the way that you define your affinities changed a lot there. You had global services, so that was something to note. Again, we touched on secrets a little bit earlier. Rolling updates, being able to update, of course, and no downtime to your application. Health checks, and HTTP routing mesh, which is basically your service discovery. ModSquad 3 is happening right now. We're looking at past services in the cloud. We're evaluating Kubernetes and Cosmos DB. So your recipes for success. How can I create something that's not too big, not too small, and easily adopted? Well, for starters, start small. You don't want to try and containerize everything. That's something that we saw a lot. The whole stack. I want the whole stack containerized. Let's take a step back. Why do we need the whole stack containerized? Let's really see what we really need containerized. What's going to be our lowest small hanging fruit, something that I can do pretty quickly, easily adopted, and again, that's going to help your operations teams build confidence instead of saying, hey, I'm going to throw this whole thing at you in containers. I'm just going to start with little piece by piece. Buy-in from management. In big enterprises, of course, you see a lot of silos. So take this as an example. You're a manager, and you've got a team. They're building out a Docker environment. It needs to go to production, so of course you need to operationalize it. So I'm going to come over here. I'm going to talk to the operations manager. I'm going to say, hey, I need a resource. Okay, I can give you a resource. He can work with you. I'll allocate him 50% to your project. Sounds good. Great. A day goes by. You email that guy, like, hey, we've got this environment going to production. We need to go through operationalizing it. Can we meet to talk about it? Dude emails you back. Yeah, I'm available in like 2 months. So you really need to make sure that everyone's on the same page. This is going to take a lot of work to get all your teams cohesively thinking on the same page. So really making sure that the managers talk, that's a big thing. But you do see, once you do have that buy-in from management, things do go a lot more smoother, of course. With that being said, you have to make sure that you are training your teams. Ultimately, if you engineer this and something goes bump in the night, they are going to call you. And that is what we're trying to get away from. We want to make sure that our operations teams feel comfortable, they can keep this environment up and running. Of course, I said knowledge transfers before, really working with them and testing your environment. Do the war rooms. Make chaos there. Make them have to figure it out. It's really just going to help them in the long run. And with training, you have to make sure you have a lab environment. A lab environment, not just for you, but for other teams as well. We see that once I'm like, okay guys, I want to do Docker. Everyone's like, yeah, let me do Docker. I want to do Docker. But how can they get started? How do you enable your application teams and your other peers to be able to actually develop something? Making sure that you have a lab environment they can easily onboard onto. If you don't have the resources to create a lab environment for your whole company, you can definitely recommend, I recommend Play with Docker. They do have Docker for Windows and Docker for Mac, so you can kind of have your own local ecosystem. Making a better future. You need a common operating model. We have, I think, maybe 5 big data centers around the globe right now, and they all look the exact same. Why? Because it is easier to make sure we can just stamp out this, and this, and have little changes everywhere. It's honestly just going to hurt you in the long run. Making things common, having those common labels, making sure everything is uniform is extremely important. Common labels. This is going to make your life in UCP a lot easier. If you do add those labels, it makes your searching a little bit better. And again, you're getting your teams used to, this is what I should be looking for. If something's a little rogue, they can easily catch it. Good documentation. Do you guys like to write documents? Raise your hands, anybody? Oh, come on, you guys like that? No, I don't like to write documentation, but it is extremely important to write good documentation. You need to make sure that you've documented why you made the decisions that you did. In the earlier days of ModSquad, we did a lot of testing, we did a lot of pivots, and sometimes we had to go back and look at why we did what we did, so having that documentation there. Also, good documentation helps your operational teams with figuring out their issues. I see now I'm building out production environments, and once I build it out one time, I have maybe like a 40-page doc, but it tells me this is step by step how I built it, and then I can just pass that on. So that's a major thing. Keep an open mind. Keep an open mind to open source. Keep an open mind to creating your own containers. Keep an open mind to what may or may not work. I mean, in the world of Docker, you can really do almost anything. So test it out, try it. I mean, a lot of people talk, a lot of people meet. They meet all day, but actually doing it. So create your containers, throw it out there in a lab environment, see if it works the way you expect it to. And if it doesn't, just throw it away and build another one. With a ModSquad innovation team, there was a mix of junior engineers and senior engineers, and so to be able to have a voice heard is a big deal. So if you are a senior engineer, just working with your junior engineers and letting them know, hey, I do value your opinion. It's a big thing in diversity and inclusion as well. Understanding your application team. Oh man, that's a big one. So, understanding your application team, understanding what they're trying to solve. When we were figuring out if we wanted to use MongoDB, we were really trying to understand, hey, what is the problem? How are we going to solve this? How can we do it easily and simply? And at the same time, we're constantly running around trying to fix their issues, but truly understanding what their issues are. So for instance, they say, I can't deploy this stack. Okay, well, do you have the right permissions to deploy this stack? It could be multiple reasons why, but truly understanding it, we did waste a lot of time kind of just running around trying to find things. If we just got to the real bottom of the issue, we could have fixed it super quickly instead of, maybe 2 months or something. So a little recap. We talked about a little bit about Metlife. We talked about GSSP application architecture. We talked about the database architecture, the ModSquad innovation teams, and how we could have done a little bit better. What I didn't talk about was Kubernetes. Hopefully that'll be in future talks. I didn't talk about how to maintain your image, and actually I do want to go back to that. It's going to be here. Maintaining your image. So if you look over at the third arrow, if you want to upgrade to, say, the next version of Mongo, I think Mongo is at 3.6 right now, simply just change out your repository, and simple enough, of course, it will create that 3.6 version. You can also, again, have this in UCD or Bamboo. So CI/CD, you just change the repository, you get Bamboo to create your build jobs, send it, push it out to DTR, and then people can pull it down for their environments. Skip back through this. Okay, awesome. And now we've got, I think, 8 minutes for Q&A, if you guys have some questions. Sure. Yeah.
If you're going to ask questions, we have a mic back there, and use the mic when you're asking questions, so we all hear. Thanks.
So you mentioned earlier that you guys had Redis as well as MongoDB. Can you describe the different use cases both are solving in your organization?
Yeah. And the GSSP application, MongoDB is not the true source of record. Again, it's just sitting in the middle as a cache. So the biggest thing was having to let people know that Mongo is a cache, so you don't have to treat it the same way that you would treat a database. People wanted to put a lot of extra things on it because they're like, oh, it's got database in the name, so we've got to make sure that it's got a lot of security, harden it, and ultimately we were just bogging down our image. So we really had to change their mindset and really make sure that they understood the use case of, hey, this is just going to be a cache. Yeah. Awesome. Anybody else? Yes.
I've heard it mentioned a lot, not running applications on the manager nodes.
Yes.
Can you tell me why that is?
Yeah, so you want your managers to have enough resources to be able to re-orchestrate. If you need to maybe have workload shifting, you should make sure that all of your workload is actually running on your managers. To make sure that you have HA with your UCP. Sometimes you might see one of the nodes goes down, and because that's a manager node, that's your thinker node, you need to make sure that that's always up. So it's easier just to, it's best practice actually to go ahead and disperse your cluster against your worker nodes. Cool. A little thing to note, all of the code that I presented today is on my GitHub page. Check it out. If you want to email me, have any questions, shoot me an email. I'm on Twitter, Janelle Taylor _. If you guys want to talk after the chat after the talk, let me know. I'd be happy to answer any of your questions. Thank you.